Section 5.3, trigonometric functions. We're going to evaluate trig functions of any angle. We're going to find the sign, positive or negative, of the trig function. We're going to find reference angles. We're going to use unit circle definitions of the trig functions and apply basic trigonometric identities. As you learned, trig functions are different ratios. Sine is a ratio, sine of an angle is a ratio of opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse, and so forth. To simplify it, we're going to form the right angles with a vertex at the origin and a terminal ray in standard position. So we're going to have something like this. We're going to have our initial ray, we're going to have a terminal ray, okay? We're going to make a right triangle. We will always be making the right triangle with respect to the x-axis. So we'll always be making the right triangle by going down vertically or going up vertically. Never horizontally. We'll never go right or left to make the right triangle. We'll always go up and down to make the right triangle. And now, instead of calling a side opposite, adjacent, and hypotenuse, we're going to call this opposite side y now, because it is y. It's the y distance on an x and y coordinate system, in the Cartesian coordinate system. It is the y coordinate. This adjacent side we will now call x, and this radius, the hypotenuse, we'll call the radius of it, or the r, because it's a radius of a circle. Why we call it r, like we make a unit circle. So we have some point xy on the unit circle. And you know that x squared plus y squared equals r squared. And theta, this theta angle right here, is an angle in standard position. So we can define sine, instead of an opposite over hypotenuse, we can now call that y over r. Cosine, instead of adjacent, we'd call it x over r. Tangent, instead of opposite over adjacent, we can call that y over x. Cosecant, secant, and cotangents are these reciprocals. So r over y, r over x, and x over y. If I am not inside one in the first quadrant, or in the second quadrant, or in the third, or on the fourth, if I'm right there, that is called a quadrantal angle. Or if I'm right there, that's called a quadrantal angle. Right there, quadrantal angle. Quadrantal angle, okay? So any multiple of 90 degrees of pi over 2 radians is in a quadrantal angle. So if we have the terminal side of an angle theta, so here's my angle theta now, I'm going all the way around there, that's the theta is, all the way around, and standard position, and it goes to the point -2, so this point here is -2, -5. Find the exact value of the six trigonometric functions. So there's my terminal ray, this red one is my initial ray. And that terminal ray goes through the point -2, -5. So what that means is my x is -2 and my y is -5. This is x direction, y direction. I don't know what r is, but you know Pythagorean theorem, so you could calculate r if you wanted. A squared plus b squared equals c squared, or x squared plus y squared equals r squared. So I have -2 squared plus a -5 squared is equal to r squared. So -2 squared is 4, -5 squared is 25, 5 squared is, or 25 plus 4 is 29. R squared is 29, so r is a radical 29. So the sign is y, which is given, -5, over radical 29. Rationalize the denominator. And when I rationalize the denominator, I'm going to multiply by radical 29 over radical 29. And I'll get negative 5 radical 29 over 29. Cosine x, which is negative 2 over radical 29. Rationalize the denominator, and you get negative 2 radical 29 over 29. Tangent y, which is negative 5, over x, which is negative 2, which is positive 5/2. Cosecant, secant, and cotangent. Reciprocal, but I would not do the reciprocal. Whoops, that should not be there. Just that one, we got one negative. I'll make that positive. Okay, because it's a negative quantity. Reciprocal. I wouldn't do this reciprocal though, because it'll be more work. I do this reciprocal. So it's radical 29 over 5. And it's negative. Negative radical 29 over 2. And 2 over 5. Like I said, I probably wouldn't even be plugging in the r and y since I have these right here. I just take the reciprocals. If theta is a second quadrant angle, so I'm in the second quadrant. There's where my theta is. And sine is 12 over 13. So let's make my angle, and remember my right triangle. And remember I told you I always go down or up to the x-axis. Sine is y over r. So there's a little picture of it. 12 is my opposite side or my y side. 13 is my hypotenuse or my r side. So we know r. I already said that's 13. And we know y. And I hope you can solve for x. X squared plus y squared equals r squared. Or you might remember this in a triangle that you memorized. And you would say, oh, that side is 5. But I wrote negative 5. And the reason I wrote negative 5, because I'm in the second quadrant. And in the second quadrant, x is negative. That's what I've written here. Must be negative. Okay? So if you memorize it, that's fine. If you do it from the formula here, you solve it, you get plus or minus 5, and then you look at what quadrant it's in. And then you realize, oh, I'm in the second quadrant, so x is negative in that quadrant. And now that I have all of them, all you do is plug in what you know. So sine was given already. Cosecant's reciprocal. Cosine, negative 5 over 13. And let me write it there. Reciprocal, negative 13 over 5. And y over x would be 12 over negative 5, so negative 12/5. Or negative 5/12 for the cotangent. And you're done. So remember what quadrants you're in. If you're in the first quadrant, everything's positive in the first quadrant. And you should know that. There's x-axis, this is y-axis. In this quadrant, x and y are both positive. And that's my first quadrant. In my second quadrant, I hope you know that x is negative, but y is still positive. In the third quadrant, x is negative, y is negative. And in the fourth quadrant, x is positive and y is negative. And that's what I have right up here. So I filled the table out. So when we're doing it, in quadrant 1, everything's positive, x and y. So everything's positive here. Sine, cosine, tangent, and its reciprocals. In quadrant 2, this is y over r. In quadrant 2, y is positive, r is positive, and r is always positive. So we know that sine is positive because it uses a y. Cosine, though, is x over r, so it's a negative over a positive. So that would be negative. And tangent's y over x, so that would be a positive over a negative, which gives you a negative. So that's what they are in those quadrants. In quadrant 3, x and y are both negative, so I'll have a negative over a positive, gives me a negative. Here I'll have a negative over a positive, which gives me a negative. And here I'll have a negative over a negative, which gives me positive. And in the fourth quadrant, x is positive, y is negative. So I will have a positive here. I'm sorry, x is positive. I'll have a negative here because y is negative. Here I'll have a positive. And y negative over positive is a negative. So in the fourth quadrant, negative over positive, positive over positive, negative over a positive. And that's what they are in all the quadrants of positive and negative. And that's what I have written on this table. Sometimes people like mnemonics to remember where things are positive, where things are negative. There are different things that you might want to remember. You can remember the word cast, C-A-S-T, but starting in the fourth quadrant. C stands for cosine. So cosine and its reciprocal are positive in the fourth quadrant. A stands for all. All are positive. S stands for sine. Sine and its reciprocal are positive in the second quadrant. And T, tangent. Tangent and its reciprocal are positive in the third quadrant. That's one way you can remember it. Another way sometimes people remember is all students take calculus. So first quadrant A, all. Second quadrant S, for students and sine. Take, tangent, calculus, cosine. Okay? And remember its reciprocals will be the same sign. So you need to know that. Reference angles. You can reference all angles back to the original angle in the first quadrant. And the reason is, if I'm just in this first quadrant, I might have some angle there. Okay? Which is theta. There's my reference angle. If I'm in the second quadrant, I can draw a right triangle, and even though this is theta, I could call it the sine of the reference angle. So there's my reference angle. Reference angle always with respect to the x-axis. So the reference angle in the second quadrant would be 180 puts you right here, minus this theta here gives you the reference angle right there. Okay? If I'm in the third quadrant, so let me pick one in the third quadrant. So I might go all the way around here. Okay? This is some angle theta. I hope you know from here to here is 180. So if I take theta minus 180, I'm left with the reference angle. That's what I wrote here. If I'm in the third quadrant or fourth quadrant, my reference angle will be right there. There's my reference angle. I said always make your right triangle with respect to the x-axis. Here's my reference angle. If I go all the way around, it's 360. If I subtract this angle theta here, I'm left with the reference part. So to the right here, and to the left here, I have what the reference angles are in the quadrants. If I'm just in the first quadrant and I'm just going nowhere else but the first quadrant, theta is my reference angle right there. You can also do this in radians. If you're in radians, 180 degrees is pi, so you could do pi minus theta. Here you could do theta minus pi. Theta. And here you can do 2 pi minus theta. So I can put everything in terms of a reference angle, and I'll do some examples in a minute. So let's find the reference angle for 120. Think about where 120 would put you. 120 think about a picture where it puts you, 120, puts you in the second quadrant. So you want to figure out what this angle is there. So you would do 180 minus 120 to give you your reference angle. It's in quadrant 2, and you do 180 minus 120, and it gives you 60. 195 puts you in the third quadrant. So in the third quadrant, you would do 195 minus 180 to get a reference angle of 15 degrees. If theta is 300, it puts you in the third or fourth quadrant, because 300 degrees is the fourth quadrant. And so my reference angle then would be 360 minus 300. It gives you 60 degrees. And two different ways you can think about the reference angle for this one. One, you could just draw a picture and see it right away. If I'm going 20 degrees that way, my reference angle is 20 degrees. I'm in the fourth quadrant. You could also do it mathematically, just like we did. You could, your reference angle is 360 minus a negative 20, because it was 360 minus theta, and you get 380. But remember, coterminal, I can add or subtract 360 degrees and I'll be in the same spot. So you can also subtract 360, and that's how you get 20. Because reference angles will be less than 90 degrees. 380 is not less than 90 degrees, so you need to subtract a whole circle. So now we know something about reference angles. We can find the sine, cosine, tangent of anything in terms of a reference angle. So sine of 135. You need to think about this. Sine puts me in which quadrant? And 120, 35 puts you in what quadrant? And you would say, oh, that puts me in the second quadrant. And in the second quadrant, you can say to yourself, is sine positive or negative? And I hope you know it's positive. So this is equal to positive sine of the reference angle. And the reference angle would be 45 degrees. Cosine of 310. 310 degrees puts you in the fourth quadrant. Cosine is positive there. So you could call this cosine, and it's positive cosine, of my reference angle. And my reference angle is 50 degrees. Sine of 210 degrees. That puts me in the third quadrant. In the third quadrant, sine is negative. So number 3 here is equal to negative the sine of my reference angle. So your reference angle is the 210 minus 180, which is 30 degrees. So it gives you negative sine of 30 degrees. Cosine of 112 puts you in the second quadrant. In the second quadrant, cosine is negative. So it's negative cosine of my reference angle. And when I do the subtraction, I get negative cosine of 68 degrees. And if you want, you don't believe me, pick up your calculator, put in the cosine of 112, and then put in the negative cosine of 68. Make sure your calculator's in degree modes. You should get the exact same answers. So you can do stuff in terms of reference angles. Again, you don't have to memorize the unit circle if you understand it. This is 0 or 2 pi or 360 degrees. You can break it up into 6. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. 1, 6, that's 2, 6. This is 3, 6 reduced. This is 4, 6 reduced. 5, 6, 6, 6, 7, 6, 8, 6, 9, 6 reduced. 10, 6 reduced. 11, 6, 12, 6. And then you could break it up into fourths. 1/4, 2/4 we have, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. And I also have the degrees written here. Degrees you usually seem to understand a little easier. Okay? Around the unit circle, If you think about the unit circle, I'm going to tell you that this is 1 unit. From here to here is 1 unit. The radius is 1 unit. That's what we're talking about with a unit circle. Okay, radius is 1. So if you're at certain points, like right here, if this is a unit circle, this is a point 1, 0. This means your x is 0, your x is 1 and your y is 0. If you're right here at 90 degrees or pi over 2, that's 0 over and 1 up. Remember, your x is 0, your y is 1. If I'm over here at this point, if the unit circle, x is negative 1, y is 0. If I'm down at this point, x is 0, y is negative 1. So around the unit circle, those are your x's and y's. So if I wanted the sine of 0 degrees, that would mean that I am right here. And sine of 0 degrees is y over r. Y is 0. And I said this is 1 unit, that's your r. R is 1. So 0 over 1, sine of 0 is 0. If I asked you the cosine of 0 degrees, x is 1, y is 1, so it's 1 over 1. Okay? Let's say I asked you the tangent of 90 degrees. Remember, tangent is y over x. So at 90 degrees, I'm right here, up here. Y is 1, x is 0, which is undefined. Okay? So at those quadrantal points, you can say x is 1, or negative 1, or x is 0, or the y points will be 0, 1, or negative 1 at the quadrantal points if you have a unit circle. And this is where you also need to know 30-degree triangles. So if I give you a 30-degree triangle, I would draw the triangle, and hopefully you have memorized 1, 2, radical 3. You can look online to see the homework for this section.